Arctic lunch.
We're taking you inside some of the coolest labs at NASA's Kennedy Space Center to witness how scientists and engineers are discovering how to live.
We can't bring everything with us from Earth.
And work.
Shelters, launch and landing pads.
On the moon.
It's science you can eat.
Science you can eat.
So let's try some.
Good, because I'm hungry.
See for yourself how NASA is reimagining life as we know it for the lunar surface.
Okay, so I just press print?
Yeah, go for it.
I'm gonna print something out of lunar regolith.
You think you know NASA? Well, think again. I'm Megan Cruz. Come with me to experience the extraordinary, the unexpected. This is Far Out. Humanity has long been fascinated by the idea of going to the moon. But it wasn't until President Kennedy said,
"We choose to go to the moon in this decade,"
that we made it a reality. His challenge sparked NASA's Apollo program, and suddenly, the impossible became possible. Astronauts first landed on the moon in July 1969. And NASA kept sending astronauts there until December 1972 with Apollo 17. That looks like fun. But the longest any of those astronauts spent on the moon was about 3 days. Now, through its Artemis missions, NASA wants to return humans to the lunar surface for much longer. First a week, then eventually months. Not just to drive them through the world again.
Please my channel subscribe. मैं बहुत अच्छा से वीडियो बना रहा है, आप लोग सब्सक्राइब करो.
What are the things you need when moving to a new place? Well, for one, you need a place to live. Lucky for us, we know people in the lunar construction business.
This is SwampWorks. This is a lab that's all about innovation.
And has been for decades. Before SwampWorks, this was Kennedy's astronaut training building, where they practiced landing on the moon. Now, Nathan and other researchers are here to transform lunar regolith. What the heck is regolith? It's essentially the moon's version of soil, but it's nothing like our soil. It's more like coarsely ground up volcanic rock that can cut like glass, and dust so fine it gets everywhere. Just ask some of the 12 men who walked on the moon.
Although the surface appears to be very fine-grained as you get close to it, it's almost like a powder.
NASA wants to use this regolith to build homes and other structures on the moon.
This would be a structure, unpressurized, kind of like an open garage. It will also have regolith piled over the top of it, and the regolith will provide astronauts protection from the radiation that we have on the moon, and it will also protect them from meteoroid impact.
But it looks like you also have some rope here and...
Yeah, these are other really cool things that you can make.
And so what is this?
This is called basalt glass fiber. You melt the regolith and pull it into very fine strands and then weave it into different fabrics and ropes and other things that are useful for infrastructure.
Wow, this is super impressive. It doesn't feel like something that was made out of rock.
NASA would also want to build a launch pad.
Imagine landing a rocket on Cocoa Beach. The sand would fly everywhere, right?
Yeah.
Well, if you have a bunch of equipment sitting next to it, you don't want it to get sandblasted.
Right.
So we have to prepare a surface where rockets can land on.
How would you do that all on the moon? With this machine, of course.
Oh, I thought this was a coffee machine. I was going to ask you for a latte after this.
Sometimes I wish it was a coffee machine.
Instead of coffee grounds, Nathan says we'd pour in regolith and plastic to make moon concrete. Better than bringing our own concrete from Earth, because that would be expensive. You'd need about 125,000 tons of concrete to make a launch pad. That would take thousands of launches to get all that concrete from Earth to the moon.
So can you show me how this all works?
Sure.
Can we make some pellets?
Let's do it.
Okay.
Before we begin, we mask up so we don't breathe in the regolith. By the way, this is not real lunar regolith. It's crushed up rock from here on Earth that Nathan says is very similar to the real thing.
See how it's very
it's
dusty?
so fine, yeah.
So be very careful dumping it in.
Okay, oh, it's heavy. How much do I dump in?
Keep going. Keep going. That's good. And here's the plastic.
Okay. So just pour some in this one over here?
Yep.
Okay.
Now it's time to start up the machine.
All right, hit this button.
Yeah, you got it.
Okay.
And now the machine starts to run.
And faster than you can say espresso, it starts melting the plastic first.
So now you can see we have plastic
Oh,
coming off.
whoa. Okay, yeah.
This is not how it usually looks
Okay.
because we don't have the extruder nozzle on.
Okay.
But you get a chance to at least see what the material looks like.
Looks like snot. So when do we add the regolith?
I think we're at a good point to add the regolith
Nice.
right now.
Okay.
Okay, so now you can see the regolith is also going in.
Oh, right. Now something's coming out of this one.
Yep.
This mixture will get darker and then will be cooled in water before it's cut up into pellets. Then those pellets would go into a 3D printer. For that part of the process, let's go to Jaden Chambers, a robotics and automation engineer.
And here we're able to monitor and control the temperatures. We're able to see the printer in action while also manipulating the offsets, the speeds, the position. If we want to start the print, I just go over to this tab right here where we see all of our files. Click on this NASA logo and you can go ahead and just click print and it'll start it right on the printer.
That's it. That's all
Yep.
I need to do.
That's all. Just
This
clicking
is
a button. Yeah.
easier than the printer in my home office that keeps breaking down. Okay, so I just press print.
Yeah.
Whoa!
There it goes.
This printer was designed and built by NASA from scratch. It's faster than most other 3D printers and can print bigger things.
Right now, this material has the structural properties of wood, meaning like when we put it through strength testing, it is as durable as wood would be.
The goal is for their moon concrete to have the best qualities of both wood and concrete. Jaden loves the challenge.
You know, since we're kind of pioneering this thing, we can't really predict how it's going to act until we actually test it ourselves.
The other challenge is scaling up productions, make more concrete, print bigger things, and to combine the two machines into one. Look, they're already making great progress.
As one machine.
Yep, exactly.
Wow. So the machine that we looked at before
Yep.
and this machine
Combined.
together,
Yep.
doing
and
it all on
hooked
its
up
own.
to a giant robot arm.
Wow.
In the end, remember that launch pad? Nathan wants to be able to build that pad within 2 weeks. Incredible, right? That would typically take months. But what about what we're printing right now? It's still going, but lucky for us, we can fast forward. After speeding through about 40 minutes,
Oh, it's really stuck on there, huh?
Yep, there we go.
Whoa.
And you can go ahead and pick it up.
Oh, really?
Yeah.
It's not. So it's not going to be
No,
hot.
it'll be cool. Go for it. It
Oh,
hardens
wow.
almost immediately after hitting the bed.
Oh my gosh, it's just like a little warm.
Yeah.
I'm surprised because you said the nozzle was how-
200 degrees Celsius. But as soon as it comes out and hits the air, it cools down just like that.
while the science and technology is impressive, I'm also impressed by Jaden.
Did you ever expect that you would be working on building structures on the moon?
Never in a million years. I started in fast food, you know, but I had like a vision in mind that I wanted to obtain, and I just started reaching for the stars, and here I am.
Well, we're lucky to have you here at NASA to make these structures on the moon, like we were saying. What do you think about me taking this as a souvenir?
Go for it, yeah.
Taking it
It's
as a
yours.
souvenir.
There you go.
So, NASA is working to make its own material to build structures on the moon. But before you can bake that cake, so to speak, we have to gather the ingredients. NASA has a plan for that too, using clever excavation robots like this one. Let's check it out on the other side of the SwampWorks lab with lead robotics engineer Drew Smith.
Nice to meet you.
Hi, nice
Name's
to meet
Megan.
you too. Hi, Megan.
And what are you showing me today?
So this here is our big bin. We call it the big bin because it's full of 120 tons of lunar regolith simulant.
Can we see into it?
Yeah,
or-
let's open up the door and take a look.
Oh, nice. Yeah, it's like you're literally on the moon.
And yes, we're totally getting in there. But it's kind of hard to hear one another inside, so we're gonna chat out here first. Drew says NASA uses different kinds of regolith simulants. What's in here is crushed volcanic rock from Arizona. And if you're wondering what that feels like,
It really sticks to your hand. I mean,
Yeah, it really
just
does.
did this a little bit and now it's all over my hands.
Yeah, it's a super interesting type of simulant.
There's no way to really get it off.
Yep, you just got to wash it off with water, and this was one of the major challenges that the Apollo astronauts had when they did their walks on the moon.
We talked about that with Nathan too. Later in the episode, we'll show you what NASA is doing about it.
So and I see you have a rover in here, so what's with that?
Well, we can't bring everything with us from Earth, so we have to be able to excavate what is there on the moon.
I see.
To convert it into oxygen and water and everything else to be sustainable.
How would that work?
Basically, everywhere on the moon that you go, the dirt contains oxygen in it. We have to be able to dig the dirt to bring it to a processing plant.
So you can actually get oxygen out of the dirt.
That's right.
Sounds like a great plan. However,
you can't bring a big bulldozer with you on your rocket, right? Because it's too big, too heavy.
Sure.
So NASA's small solution for this big problem, da-da-da-da, Razor.
So this robot's special because it's the way that it digs.
Think about a backhoe here on Earth. Its massive weight keeps it on the ground while it digs on one side. But remember what Drew just said, we can't deliver a heavy machine to the moon. But with Razor,
you're digging on the other side as well.
Digging on both sides keeps it on the ground. That way, you don't need it to weigh a ton. But where's the steering wheel?
Yes, it's a video game controller.
I would not have expected that.
Yeah, we use these controllers for lots of different reasons. They've gone up through a lot of ergonomic studies, right? So they make these things really easy to hold, get to all the buttons, and the software makes it really easy to map all your different operations with your buttons. So
nice.
This is what we use to control a robot.
I will preface this with I haven't played video games in a very long time.
So I get a few tips.
Yep, it's actually really simple.
And off we go.
Should I try to go over this rock?
Yeah, you can drive over top of it. Kind of go and hit it with one of your wheels.
Oh! And so how do you dig?
So digging, you would put the arms down to dig.
Okay.
And then you would turn the drums on.
So now that we've taken it for a spin, it's finally time to get in there. But Drew says I have to hop into a bunny suit.
Kid size, please. I haven't put on a bunny suit, actually. I don't think since I've been here at NASA. This is my first bunny. I think so. Yeah, look good, right? Look good. I know. A little close there, aren't you, Glenn?
Right away, I notice a remarkable difference between this dirt and anything I've experienced before.
Oh, yeah. It's like it's water. Like, I don't know how to...
It's a really interesting type. So you can kind of see, like, if I take just like the least fluffy material away, it's like super hard.
Yeah.
Right?
Why does this feel so different than like our dirt?
It's about the particle size and the particle shape.
Thanks to weather and time, the particles on Earth are worn down into a round shape. Think of the ocean waves rolling constantly over the sand. The moon, however, gets more of a sledgehammer treatment. Those particles haven't been weathered. They've been crushed by asteroids slamming into the surface. That creates the small, jagged particles covering the moon.
Is it just me, or do you want to like make a sandcastle or a sand angel? You know what I mean?
Yeah.
Have you made a sand angel?
I cannot confirm or deny that, but...
All joking aside, this big bin is such a huge asset for NASA. All this regolith simulant, 120 tons of it, allows engineers to test machines like Razor in an environment that really mimics the moon. And what they're learning from Razor is now helping them build a smaller version called IPEX. It's IPEX that will eventually help our astronauts live and work on the lunar surface.
That was a really cool experience.
So it's always fun to work for what your passion is, right? So robotics and digging, excavation, it's not even like coming to work.
When you were a kid, did you think this is what you'd be doing?
No.
Are you glad this is what you're doing?
Yes.
Thank you so much, Drew.
Yeah,
it's really
we
great
appreciate
meeting
it.
you. Yeah.
You too.
We've been learning a lot about lunar regolith and how it could be a resource for us on the moon. But it's also one of the biggest challenges of staying there. Let's meet Charles Bueller now.
Great to meet you. And this is?
This is Hollywood.
Hollywood. Who named him that?
I did.
Okay. Or why is he named Hollywood?
I don't know. He looks like a movie star.
Actually, he does. He does. Well, why is he here with us today?
He is donning an EDS suit.
EDS, short for Electrodynamic Dust Shield. Basically, scientists here at Kennedy Space Center have found a way to use static electricity to keep dust off our stuff on the moon. We know Apollo astronauts would have loved this technology.
The Apollo astronauts complained heavily about dust loading on their suits, on their visors, and in their grips of their tools and their hands. And they struggled with trying to remove the dust. Conventional methods like brushes and vacuum cleaners didn't work very well. So after 50 years, NASA's been looking into other technologies that can help mitigate the dust problem.
So we're here to see it in action. Let's say goodbye to Hollywood and follow Charles into another part of Kennedy's Electrostatics and Surface Physics Lab.
These are sample EDSs.
Okay.
They're used for demonstration purposes. We have a glass EDS to remove dust from glass surfaces, and then we have a non-transparent one for thermal radiators.
Glass versus plastic.
Yep.
Okay. All right. So how do we show this thing?
Well, what we do is we put lunar simulant dust on it.
Like Nathan and Drew, Charles is also working with a regolith simulant. His is finely crushed volcanic rock from Hawaii.
We put it on our EDSs.
All right.
So you make it nice and dirty. You don't want the astronauts to go clean it off themselves.
Okay.
You want this to be self-cleaning.
Right.
Okay. So when I turn it on,
whoa! Oh my gosh, that's incredible. All because of electricity.
Yes.
That's what's doing it.
Now don't be fooled by this easy flip of the switch. Charles says this technology is more than 25 years in the making.
Can we see it again?
Sure.
It doesn't matter how much, or?
Just a little bit, and
Okay.
just tap it over the top. Just tap, tap, tap. There you go.
Yeah, okay.
A little bit more on the other one. Put a lot on there, goodness.
Oh, so, sorry.
That's okay.
I really want to see the science work.
All right. Okay.
Is that it right there?
Okay.
Okay, and then, so what are you doing here?
I'm energizing this little tiny circuit.
Okay.
Okay. So that circuit puts out our voltage. In this case, it's about plus or minus 2,000 volts.
Okay, and how does that compare to something we have in our house?
2,000 volts is much higher than we normally have in electricity. That's a high voltage system, but it's very low current.
Okay.
So it can't hurt you.
Okay.
So if you like, you can push this button.
I would like that, thank you.
Go ahead.
So I just press this
Yeah.
one right here?
There you go.
Whoa!
You put a lot on there, so it's going to take a couple more seconds to remove, but there you go.
Okay, so it works here on Earth, but what about in space? The team successfully tested the technology on the International Space Station. So a recent launch sent EDSs to the moon. They will test if they can keep solar arrays clean.
You can't clean them easily. So we've incorporated EDSs into the cover glass of those.
Oh, wow.
They will also test the technology as a teleportation device.
This device here is a conveyor.
Oh, wow.
So you can actually take a pile of dust, remove it, and make it reappear somewhere else.
Charles wants to show me one last EDS. For that, we need to visit our friend Hollywood again, who, remember, is wearing an EDS.
And who thought to make fabric out of it?
Well, we've been making fabric EDSs for a long time.
Okay.
But one summer I had 11 interns, so I said, well, go make an astronaut suit that's self-cleaning. Told them what to do, and they had so much fun building this guy.
And when they filmed one of their tests, keep a close eye on the dust on Hollywood's sleeve. Poof! Gone! Not like magic, but science.
You love to get the young people excited about electrostatics. It's a hard field to get people excited about, but when they see something like this, it really motivates them.
And do you think it'll really make a difference and really make our goals of going farther and farther into the universe easier?
I think so, yeah, because there's going to be a lot of dusty environments that we're going to encounter.
So how do you feel, you personally, seeing this come to fruition?
I'm excited about it. I really am.
So we've been digging, building, and cleaning on the moon. I don't know about you, but all that work really works up an appetite. And that's another challenge when it comes to creating a community on the moon. Food. In the beginning, this is what astronauts could eat, and they washed it all down with Tang. Remember that? Today's meal choices are giant leaps better, but access to fresh food is still a work in progress. Just ask some of Kennedy's space farmers, Joya Massa and Trent Smith of Kennedy's plant processing area.
So first we're going to go into our controlled environment chambers, but because we've come in from outside and we may have insects on us, we have to wear lab coats and gloves when we go in these chambers to keep the plants safe.
So in here we've got tomato plants.
Oh, wow. Oh, that's amazing.
And these are an engineered type of tomato that might be a good candidate for space trees because they grow very fast. They produce a lot of fruit.
Right now, Joya and the team are testing what external conditions help or hinder growth. They do the same kind of work on the International Space Station.
Maybe different CO2 levels, different light levels, or we can test adding fungi or beneficial microorganisms.
Why are we trying to grow plants in space?
On the space station, we can send things up, and they get fruits and vegetables, but they only last about a week or so after the vehicle docks. But when we go to Mars, there won't be any option, besides growing our fresh vegetables if we want those. There's no grocery stores.
But I was not born with a green thumb. So, thinking about growing plants in space, how do you plant and water crops with little to no gravity? What would moon dust or space radiation do to those crops?
Yeah, we have a whole list of challenges. Even things like, figuring out which plants to grow well in that environment, how to keep them very small. Like these tomatoes are very small because we don't have a lot of space to grow plants.
Yep, space is a problem in space.
Wow, this is so cool. So what are these?
So these are different lettuce plants.
Okay.
We're now in another chamber where they're growing lettuce to see how this vegetable responds to different shades of light.
It looks kind of like a nice daylight spectrum, right? But it's made up of blues, reds, greens, and whites set to different intensities.
Joya says changing the light spectrum could change how these taste.
They have a lot of unique responses to light, and we're still learning what those are. So we're working through this process with a lot of different crops.
But one thing's for sure, whatever they choose to grow for longer, farther missions must adhere to the strictest of criteria. That they grow well, produce a lot of food, are safe, nutritious, and delicious. All this talk of food is making me hungry.